The first thing I need you guys to do is to write down the cofunction formulas on your note card from lesson 7.3, as I never had you write these down. These cofunction formulas are all involving half pi minus theta. Well, on the screen you see it says half pi minus u. I really don't like using the letter u, so instead I use the letter theta, the Greek symbol theta. But you've got one for cosine, you've got one for sine, you've got one for tangent, one for cotangent, one for secant, and one for cosecant. So please jot these down on your note card. If the substitute teacher could pause right now until everyone is done, and then proceed. So now, using those cofunction identities, it says problem number 1, express as a cofunction of a complementary angle. So it says the sine of 15 degrees 20 minutes. If we're referring to this cofunction identity, sine of u equals the cosine of half pi minus u. So we'll simply change this into the cosine of the complement, which would be 74 degrees and 40 minutes. I got the 74 degrees 40 minutes by finding the complement of 15 degrees 20 minutes. Part B now, cosine of 73 degrees 12 minutes. We're going to be using this one right here. And so that's equal to the sine of the complement, which would be the sine of 16 degrees and 48 minutes. I got the 16 degrees 48 minutes by simply finding the complementary angle of 73 degrees 12 minutes. Now in part C, it's the same kind of deal, except for it's with a radian measure instead of a degree measure. And since it says tangent, we're going to be using this one, number 4. So the tangent is equal to the cotangent's complement. So we're going to have the cotangent of the complement of pi over 6, which would be 5 pi over 6. No, sorry. 2 pi over 6. That would make sense to simplify that into pi over 3. And then lastly, part D, we have the secant of 17.28 degrees. Thus, we're going to be using this formula here, the 6th one. It's equal to the cosecant of the complement. And so the complement of 17 degrees 20.28 would be 72.72 degrees. So that's using your cofunction identities. That was homework problem number 1. Next, homework problem number 11. It says express as a trigonometric function of one angle. Well, if you look at what we have here, this is very similar to the pattern that you have for the difference for cosine. If you would imagine that this is angle A and this is angle B, what I have now, I can rewrite this as the cosine of 70 degrees minus 53 degrees, which I would then simplify into the cosine of 17 degrees, and that is my solution. This is more of a recognition problem as to which formula is this set up like. Since the pattern goes cosine, cosine plus sine, sine, it is the cosine difference identity. Next one, this is homework problem number 17. Use the given conditions to find the exact value of the expression. Well, they're telling us the sine of angle A is negative 5/13, and they're telling us the tangent is greater than 0 or positive, and we need to find the sine of angle A minus pi over 3. Well, sine of angle A minus pi over 3 is equal to the sine of A, the cosine of pi over 3, minus the cosine of A times the sine of pi over 3. Now, since we know that the sine of angle A is negative 5/13, I'll put that value in for the sine of A. The cosine of pi over 3 is 1/2. we don't know the cosine of angle A. We're going to have to put a value in for that. And then the sine of pi over 3 is root 3 over 2. So how do we find the cosine of angle A? Well, to find that, I would draw a picture of a right triangle in the third quadrant. Now, why did I draw it in the third quadrant? Because it says the sine is negative 5 over 13. And it also tells us in the original problem that the tangent is positive. The third quadrant is the only quadrant that has a negative sign and a positive tangent. So if I use the Pythagorean Theorem to find the other side, I'm going to get a negative 12. And so now using that right triangle, I'm going to substitute in the cosine of angle A as negative 12/13. This answer will now simplify into negative 5 over 26 plus, because we got a double negative, 12 square root of 3 over 2. So my final answer, I could leave it like, whoops, that's over 26. I could leave it like this, or I could put those together and write my answer as this. Either one of those answers works out fine. Next, problem number 23, it says if angles A and B are acute angles. Now what does it mean to be acute? It means that both A and B are less than 90, such that the cosine of angle A is 4/5 and the tangent of angle B is 8/15. Then it wants us to find part A, the sine of angle A plus B, and part B, the cosine of angle A plus B. So we got to use our identities for this. Sine of A, cosine of B, plus cosine of A, sine of B is what we have here. Now I'm going to need to put in 4 values from the given information up above. Now if we go to the given information up above, let's see here, it says the cosine of angle A is 4/5. So I'm going to draw a triangle in the first quadrant, and since the cosine is 4/5, I put a 4 on the adjacent, a 5 on the hypotenuse. I could use the Pythagorean Theorem to come up with the opposite length, which would be 3. This is for angle A. If I do the same kind of thing for angle B, now angle B, it says the tangent is 8/15, which means the opposite length is 8, the adjacent length is 15. If I were to use the Pythagorean Theorem to find the hypotenuse, I'd find that it's 17, and this is for angle B. So now I'll use those two reference triangles to help me with this problem. The sine of angle A is 3/5. The cosine of angle B is 15 over 17. The cosine of angle A is 4/5. The sine of angle B is 8 over 17. And now as I simplify this, we're going to get 45 over 85 plus 32 over 85, which would combine to give us a 77 over 85. And that represents the sine of angle A plus B. Well, now for part B here, it says find the cosine of angle A plus B. So to do that, we'd use the right identity, cosine of A, cosine of B, minus sine of A, sine of B. Now I'm going to need to plug in 4 values from these two triangles that we have. So cosine of A is 4/5. Cosine of B is 15 over 17. The sine of A is 3/5. And the sine of B is 8/17. Simplifying now, we're going to get 85 on the bottom. Top we get 60 minus, let's see here, that's going to be a 24 over 85. And now if I subtract those, that's going to give me a 36 over 85. So we've just completed part A, found the sine of angle A plus B. We then completed part B, the cosine of angle A plus B. And then part C says find the quadrant containing angle A plus B. Well, since the sine of angle A plus B is a positive value right here, and since the cosine of angle A plus B is a positive value, that means that when you add the two angles together, A and B, you must still be in the first quadrant, because the first quadrant is the only quadrant that has a positive sine and a positive cosine. So this is quadrant 1. And that's how we go about problem number 23. Last problem I want to show you here today. It says use the sum and difference identities to find the solution of the equation that are in the interval 0 to pi. So here's an equation. What I want to do is I want to get everything onto one side. Okay, so what I'm going to do is I'm going to move this term over to the left. In doing that, I have the sine of 4t times the cosine of t minus the sine of t cosine of 4t equals 0. I just moved everything to one side. Now, multiplication is commutative. What I mean by that is 2 times 3 is the same thing as 3 times 2. So I'm going to switch these two terms around right there, and that's going to give me the sine of 4t times the cosine of t minus the cosine of 4t times the sine of t equals 0. And now, since I did a little bit of algebra here, hopefully now you can tell that this whole left-hand side is equivalent to the sine of 4t minus 1t. It's the difference formula for the sine. And then that simplifies into the sine of 3t, because 4t minus 1t just gives us 3t. This equals 0. And now it's just like the problems we were doing in lesson 7.2. Angle 3t would have to equal 0. It would also equal pi. It would also equal 2 pi, because that's where the sine is equal to the value of 0. Now, one more step is I divide by 3 in each of these equations, so t equals 0 is one of my answers. T equals pi over 3 is another answer, and then t equals 2 pi over 3 is a third solution. All of these solutions are within the interval of 0 to pi, and I used a sum and difference identity to attain those angles. Hopefully this helps. You wrap up the finishing touches on lesson 7.3. You should turn that in before you leave today.